Hello and welcome to the BSRIA video regarding carbon dioxide measurements and analysis. Carbon dioxide measurements are a key to checking the overall air quality in a space and are related to the ventilation rate and the occupation levels. My name is Calum Maclean and I'm the Microclimate Team Leader within the Research, Investigations and Test team here at BSRIA. The Microclimate team are involved in many indoor environmental quality aspects, and indoor air quality is a part of this. BSRIA can help with the measurements and analysis of indoor environmental quality parameters. We can supply various pieces of equipment to take measurements through our instrument solutions team, and we can help with the legislation requirements for our extensive library and technical staff members. The understanding of carbon dioxide data can be a hurdle to understanding what is happening within a room. However, I'm going to go through an example here from a sensor installed in a boardroom meeting where the occupation levels were known. So, when graphing the data from a CO2 sensor, it is good to split the data into these three areas. Good CO2 concentrations below 800 ppm, shown here in green. Medium CO2 concentrations in yellow between 800 and 1000 ppm. And high CO2 concentrations in red above 1000 ppm. All of these limits are taken from the REVA guidance for ventilation. The desk layout is shown here by these grey boxes, and occupants are shown by these red circles. The background CO2 concentration is 450 ppm in this demonstration. That was what was recorded at the time of the testing. As people enter the space, the CO2 concentration rises towards a maximum, in this case, of 750 ppm. This is based on the number of people in the space and the ventilation rate at the time. When we reach a break, some people leave and there is a decay in some of the CO2 concentration. However, when they return, the CO2 concentration then starts to return to this maximum value of 750 ppm. At lunchtime, there is another break and the majority of the people leave. The CO2 decays significantly then, but when the people return, it does increase. In this case, the ventilation was increased by opening the windows due to the temperature rising in the space. When the meeting ended, everyone left the space and the decay of the CO2 concentration follows a standard decay due to the ventilation rate within the space. This is entirely based on the peak CO2 of when everyone left and the ventilation rate at the time. The instrumentation used in this presentation can be found through this QR code on our website, and the BSRIA topic guide for indoor air quality can be found through this QR code. This discusses the contaminants and where these contaminants come from. If you'd like to find out more, you can follow this link here to our website, and thank you very much for your time.